Hello Year 11, this is another physics video with me, Dr. Beck. Today we're going to be looking at something called free body diagrams, and this is for only higher tier students. So already we've studied how forces act upon objects, we've looked at interaction pairs, we've looked at resultant forces, and recently we've looked at something called the center of mass. Now this last thing is going to be related to our topic today. If we look in our booklet, we see that free body diagrams are very useful. When solving problems concerning the forces of an object, on an object, we can draw a free body diagram. This shows the object as part of a system, and it shows all the bits we need for that system. All the forces acting on the object and nothing else. So we can have a really complex diagram like this. This could be a Christmas tree branch, and we know at the end of our Christmas tree branches we have this shiny bauble, this glass ball, nice and colourful. Okay, great. However, we don't need to draw all this. This in physics, this is not necessary. We know there's a force keeping it up from falling down to the ground, and we know there's an interaction pair acting in the other direction, the tension. And that's really all we need to do. We need to consider these two forces in relation to this object. So we don't need to draw all this. Previously we've looked at the center of mass, and we can consider a center of mass as being where forces act upon, for example, weight due to the action of gravity. So our simplified free body diagram is much simpler, and it can either be just a circle or a dot, and that's it. We could label it, and often you might need to in a diagram, but that's all we need to consider. Then if you return back to our bauble diagram, we can draw an arrow to show the force acting down. We can label that the weight, and an interaction pair, the tension force. And that's all we need to do. So this is a free body diagram. If we draw it in a simpler form, then we can consider our dot. The weight is acting downwards, and the tension force is acting upwards. Now it's important to draw this dot so it's an obvious dot. If it's too small, it will get lost in the line. So that's our hint and our tip. I'm going to do one example, and you can have a go at the rest of those questions. Here we have a free body diagram. We're asked to draw a free body diagram for the weight. Okay, so what we mean by the weight is this thing here. Perhaps we should call that a mass, but for now let's keep it at that. So here is our free body diagram, nice and simple. And this is wrong. The weight should be acting downwards. So apologies for the error in the booklet. The weight is the force acting downwards, and the tension is acting on the string. Okay, so there's a tension force. Remember, we're talking about the mass or the weight. So it has weight, the force acting down. There's a tension force acting upwards. Okay, so apologies for the diagram. This diagram is actually wrong. I'm going to just correct that. This is the tension force. And this is the weight. Okay, so let's have a look at the others. We have got, I think, 5 more to do, B, C and D. And then over the page we can have a look at E and F. So I'm going to stop the video and you should pause the video and then we can move on and check our answers. So stop the video. I'm going to give you 5 minutes. Okay, welcome back. Let's have a look at those diagrams. Hopefully you didn't find them too difficult. Once we get past the idea, the concept, the actual application becomes fairly simple. So part B, draw a free body diagram for the lawnmower. Now we're not looking at up and down forces here, we're looking at side to side on a horizontal plane. So we have a push force and there is some resistance. In this case, the arrows are not the same length, the same size, so that suggests the forces are not equal on this lawnmower. Okay. Part C, draw the free body diagram for the Acrobat. Again, we don't need to spend 10 minutes drawing a person on a swing or on some kind of trapeze. We simply draw a circle. Gravity will be acting to produce weight, and the normal force will be stopping that person from falling. Okay, check our answer, correct it if you need to. Part D. This time a sledge. Even though it's tempting to draw a sledge because it's nice and simple, in free body diagram we don't and we shouldn't. The friction force is acting in this direction and there's a tension force in the opposite direction. Nice and simple. I'm going to do E and F together. So E, we have the smaller weight, and F, we have a baby in that apparatus. So the weight is here, the mass we should call it, the mass is here. There's a force acting on the mass which produces weight, and then there's a tension force in that string. And then for the baby, again, the same principle, a nice circle. The weight of the baby produced by gravity, acting on that weight, actually on that mass, and a tension force acting upwards. Okay, so that was free body diagrams, part 1. We'll follow soon with free body diagrams part 2, in which we also look at resultant forces.